Now in this video, we're going to answer the following question. Find the following integral. And we've been given the expression 5 multiplied by the tangent of x multiplied by the secant of x raised to the power of 4, which we need to integrate with respect to x. If you find this video helpful, please consider leaving a like, a comment, sharing this video, and subscribing to our channel for more content like this. Integration is the undo button for differentiation. If differentiation tells you the rate at which a function is changing, integration takes that rate and works backwards to find the original function. Because we are reversing the process, we call the result the antiderivative. However, since differentiating any constant, like 100, results in 0, we always add a plus c to our solution, representing the lost constant that could have been there originally. The reverse chain rule is a technique used to integrate a function that was created by the chain rule. The chain rule is applied when a function is nested inside another function. By assigning a variable to the inner function whose derivative is already present inside the function, we can differentiate that variable and substitute the x terms with u and du before integrating a much simpler expression in terms of u, and to finish, substitute u back into the solution. To begin, if I is equal to the integral of 5 multiplied by the tangent of x multiplied by the secant of x raised to the power of 4 with respect to x. Then the inner function we need to differentiate is the secant of x raised to the power of 4. So, by setting y equal to the secant of x raised to the power of 4, then u is equal to the secant of x when y is equal to u to the power of 4. Differentiating both y and u gives us dy by du equal to 4u cubed, and du by dx equal to the secant of x multiplied by the tangent of x, which is a standard trigonometric derivative that we can find using the quotient rule, but we are generally expected to remember. Now we can apply the chain rule, which tells us that dy by dx is equal to dy by du. multiplied by du by dx. And substituting the derivatives we've just found gives us 4u cubed multiplied by the secant of x multiplied by the tangent of x. We can substitute the secant of x for the variable u, giving us 4 multiplied by the secant of x cubed multiplied by the secant of x multiplied by the tangent of x, which simplifies to give us 4 multiplied by the secant of x to the power of 4 multiplied by the tangent of x. Earlier, we called this the reverse chain rule, and that's because we can integrate the solution to get the expression we differentiated. In other words, the integral of 4 multiplied by the secant of x raised to the power of 4 multiplied by the tangent of x with respect to x is equal to the secant of x raised to the power of 4 plus c, the constant of integration. This isn't our final answer, however. The expression we were given to integrate had a coefficient of 5, not 4. So we need to multiply our solution by 5/4, effectively swapping the 4 for a 5. So I is equal to 5/4 of the integral of 4 multiplied by the secant of x raised to the power of 4 multiplied by the tangent of x, which is equal to 5/4 of the secant of x raised to the power of 4 plus the constant c. For more explanation and examples of integration questions and techniques like this, search our channel for integration. As an extension to this question, what would the integral be if the secant term was squared instead of raised to the power of 4? For a hint, look in the comments section and post your answer there. So the answer to this question is 5/4 of the secant of x raised to the power of 4 plus the constant c. Please follow us on Instagram, TikTok, and Threads for daily maths content.